Well, hello, this is Dr. Dell, and this is going to be a review of the geometry that you've learned in the Practical Math Foundation course. Now, as you know, in that course, you were given essentially 18 lessons. These last two were previews of things to come. And with these 18 lessons, you've actually learned now essentially all of the geometry that you need for practical mathematics if you're going to go into industry or the military or whatever. And this will enable you to solve all sorts of practical math problems. And this is going to be an overview, review of that for you to go along with the supplementary problems that you've been given. Now, as you know, you have already studied a lot about the practical algebra you'll need as the tools for practical math, and you've also studied the calculator and how to use the calculator, the TI-30XA, and then in the section on geometry, you're going to have about 19 lessons on geometry, and each one of these lessons, of course, will be accompanied with exercises and then a quiz, as it always is. And the way we start you out, of course, is to discuss with you an introduction to geometry. What is it really all about? And of course, as you know, geometry is about physical objects in the real world. It's what we use to model things in the real world. And then we use algebra as a tool to solve unknowns in geometry problems. And as I've told you many, many times, mathematics is like a sport. You're going to learn by practicing and doing mathematics. And that's why we have a video lesson where often we ask you to pause the video and to do things along with us. Then we give you a lot of exercises so that you can play with the geometry and you can practice with it. And then once you think you've mastered a topic, you're going to take a quiz to prove to yourself and anyone else that cares that you've learned it, because it's kind of like climbing a ladder. And so what you do in this course and what you've already done is you've played the game. Now, repetition and review are very, very important, and that's why we're doing this review for you, so that you can have a quick review of it and do some additional problems as practice if you care to do so. Okay, as you know, we always like to begin at the beginning, and the most basic concept in geometry is the concept of a straight line, and we talk about that in lesson 2. Now, a straight line, as you know, is just something you can draw with a straight edge, and it represents the shortest distance between 2 points, for example. And, of course, then this would be a non-straight line, a curved line. And then in lesson 2, we also talk about the concept of angle. If you have 2 straight lines that intersect each other, they form, this is called an angle, this is called the vertex, and you can measure this in degrees. And of course, as you've learned and as we teach you, there's 360 degrees in an entire circle, and so you can measure how many degrees are in an angle. And indeed, on your calculator, there's a degree key, so you can do calculations with angles. And that's essentially what we tell you then in lesson 2. Now, in lesson number 3, we talk about parallel lines. This is one of the most fundamental and important concepts in geometry. And 2 lines are said to be parallel if, in fact, they track each other. So that means if you extend these lines indefinitely in either direction, they never intersect. That also means that, of course, that the distance between these 2 lines will be the same no matter where you measure it. The perpendicular distance will be the same. And it's important that you understand all about parallel lines. Now, one of the things that we teach you, of course, that you learn is if you have a line that cuts through 2 parallel lines, which is called a transversal, that creates 8 angles, and they're equal in pairs. This angle is equal to this angle because these are vertical angles. It's equal to this one because these are alternate interiors, and that's equal to this one because vertical. So these 4 angles are equal. And in a similar way, these 4 angles are equal, and that's what you need to understand about parallel lines. That's really the essential thing you need to know. And in fact, if you add up the degrees of 2 interior angles, like this angle plus this angle, that'll be 180 degrees. And that's the other thing you learn, and that's what you learn essentially in the lessons on parallel lines, which you'll then use throughout the study of geometry. Now, lesson number 4, we talk about the most important polygon in geometry, which is a triangle. And a triangle is simply any 3-sided figure where you have 3 straight lines intersecting. And that means you have 3 angles. And that means you have 3 vertices. These are called vertexes. Each one is a vertex, and all 3 of the vertices. And the thing that you learn is that the sum of these angles is always 180 degrees. That's the most important thing to know about triangles. And indeed, we prove that by constructing a parallel line up here, parallel to this one. And we do that this angle equal this one, this angle equal this one. And when you add these up, you get 180 degrees. And that proves the sum of these angles is 180. We also prove that the exterior angle here is equal to the sum of the two alternate interior angles using a similar argument, and that's what you need to know about triangles in general. And then, of course, we have some special cases we'll talk about in a moment. This is a right triangle where this is a 90-degree angle. This is a perpendicular line. And then this will be an acute triangle. This will be an obtuse triangle. And we define those where this is greater than 90 degrees. That's obtuse. And we gave you that terminology, and that's what we talked about for triangles. Now, in lesson number 5, we talk about what are called right triangles. And this is perhaps the most important of all triangles because it comes up in construction all the time. And that means that one of the angles is what's called 90 degrees. If you extend this base here, then these two angles are equal, and this is called a perpendicular line, and this is a right triangle. And then the most important thing to learn about it is if this side has length A, and this side has length B, and this side has length C, and it's called the hypotenuse. According to the Greeks, Pythagoras, A squared plus B squared, those two lengths squared is equal to C squared. And this is the Pythagorean theorem that you learn in this lesson, and you'll use this over and over and over again. And we gave you lots of problems where if you knew two of the sides, you could figure the third one. And that's very easy to do when you use basic algebra and a calculator. And of course, we gave you lots of problems to practice with this. You also learn some special cases. For example, if this is a right triangle, and if this is 30 degrees, then you learn that this side is 1/2 the hypotenuse. So whatever the hypotenuse is, this is half of it. And this side is the square root of 3/2 times the hypotenuse. You learn that. And you learn some other things. If this is a 45 degree, if these are equal and this is a right triangle, then you learn that if this is the hypotenuse, that this side is the square root of 2/2. And these two sides are equal because these angles are equal. This is what's called an isosceles triangle. Now I'm going over this very fast because this is a review. And this is the kind of thing now that you're learning up to this point through lesson 5 in geometry. Keep in mind, we don't prove theorems in a rigorous way, but we do solid arguments, and of course that's what you need to know. Well, I just noticed that we misspelled Pythagorean. That should be an A, P-Y-T-H-A, Pythagorean, and mistakes do occur, and I always get a big chuckle out of it when it happens, so there's a mistake. Now, the next thing we discussed in the training is similar triangles, G6. And this probably is the most important lesson in geometry because it's used over and over in practical math. Two triangles are said to be similar if they have equal angles. So, for example, this triangle, this angle equals this angle equals this one, and then that means the third angles have to be equal. We have the following situation. If these sides are A, B, and C, and these sides are X, Y, and Z, then we can say that A over B is equal X over Y, for example. Or we could say that A over X is equal to B over Y. In other words, we have actually several different ratios here that are equal, proportions that are equal, and that's what we know about, learn about similar triangles. Now, we can use that in many situations, and here's an example. Suppose you have two triangles, and you know these sides are 3 and 5, and let's just say these are right triangles. And let's say that this angle here is equal to this angle. And we know this length is 9, and we want to know what this unknown length is. Well, we set up a ratio. We can say x is to 9 as 5 is to 3. We have to use corresponding sides. Now that creates an algebraic equation. Then we apply what we learned in algebra to solve it. And we know that x then is equal to 45 over 3. And if necessary, using the calculator, that is 15. And that's how we can find this unknown side. Now, this is a very important chapter, and we give you lots and lots of problems on it. And similar triangles are probably something that is used in solving practical, real-world problems more than just about anything else in geometry. Well, now, in G7, we talk about what are called quadrilaterals and polygons. This is something that has straight lines for its sides, but it's more than 3. It could be 4, 5, or more. We focus on quadrilaterals here. 4. You have squares, rectangles, parallelograms, rhombus, trapezoids, and we talk about how to find the perimeters of these. And that's what we cover in G7 because this will be occasionally useful in practical math. Now, so far we've dealt with the lengths of things and angles, but then you come across the concept of area. This is very, very important, of course, in practical math. And for a rectangle, you know that the area is just the length times the width. And for a triangle, what's normally taught, if you have a base B, and if you know the height, that's the perpendicular distance to this vertex, then the area is 1/2 base times height. This is the normal formula that's given, and it's a correct formula, and you can easily derive it from, demonstrate it from what you know about rectangles. But here's something you come across in industry a lot, and you really need to understand this too. Suppose you have a triangle, and one length of one side is A, this is B, and you know this included angle is theta. Then what's an area formula? Well, it's 1/2 A times B, and now you've got to put in a correction factor, and SIN of theta is the answer for that. That SIN key is on your calculator. It's right here on your calculator, the SIN key. And so you can use that formula. Now, this is very useful in industry, even if you haven't studied trigonometry. You can just think of this as a correction factor. Now, later in the lessons on trigonometry, we teach you what this is and why this formula is true. But a lot of times you just come across formulas you need to be able to use, and this is a very practical one in practical math. Now, in Lesson 9, we talk about area, formulas for various polygons, squares, and parallelograms and trapezoids and so on, and really it just follows from what you've learned about rectangles, pretty much. Then in Lesson 10, we talk about circles. Now, this, of course, is a very useful thing, an important thing in practical math. And, of course, if this is a circle and this has diameter d, the radius is half of that, the circumference is here. We know the formula for the circumference is pi times d, or 2 pi r. And the formula for the area is pi times r squared. And of course we talk a lot about that. And in fact we even show in a demonstration where these formulas in fact come from and why they're true. Now in Lesson 12 we talk about some special properties of circles that can be very useful in practical math. The fact, for example, if you have an inscribed angle where this is the diameter, this will always be 90 degrees. And we also talk about, then of course you can apply the Pythagorean theorem to figure out certain lengths here. We talk about the fact that the tangent line is always perpendicular to the radius, and that lets us solve a lot of different kinds of problems that way. We talk about the fact that the inscribed angle here is half of the central angle, and that lets us solve other problems. And so there's a lot of things you can do, and we give you a lot of examples in this that's very useful and important in practical math. Now, so far, everything has been what we call two-dimensional. Everything's happened in a plane. But what about three-dimensional objects? You run into those in practical math, too. So lessons 13 through 18, we talk about areas and volumes of blocks and cones and cylinders and spheres, culminating in Archimedes' tombstone in lesson 18. Now, very quickly, this is what this means. Suppose you've got a block. A, B, and C are the three sides. The volume is just A times B times C. Suppose you've got a cylinder. Radius r, height h. You take the area of the base, which is pi r squared, times the height, and that'll be the volume. It's always base times height. Now, if you take the cone, you take the base, which is pi r squared, times the height, but you have to take 1/3 of that for the volume of the cone. The sphere is a little more enigmatic. You just don't have a height, you've got a radius. And it turns out the formula for the volume is 4/3 pi r cubed. Now, a big question is, where did this come from, and how can you remember it? Well, this is what Archimedes discovered. If you take a sphere and inscribe it in a cylinder, if this is radius r, then the radius of the cylinder's base will be r, and the height will be 2 times r. That means that the volume of the cylinder is pi r squared times 2r, or 2 pi r cubed. You multiply that out. Now, Archimedes discovered that the volume of the sphere, which is inscribed in here, is 2/3 of that. He wanted that inscribed on his tombstone. So if you take 2/3 times 2 pi r cubed, you get 4 pi r cubed, and that's where this came from. It's very difficult to prove. We prove this in Tier 4. In fact, there's many ways it can be proven, but we give the first proof in Tier 4, both for the volume of the cone and the sphere. And it is very, very fascinating and very, very interesting. But in the meantime, you learn these formulas and you can use them. And then that pretty much concludes what you need to know for practical math. But we don't stop there. We have 2 more lessons. The lesson 19 is asking, when is geometry not enough to do everything you need to know about triangles? Because triangles are the most important polygon in practical math. And the answer is you need trigonometry. And so this is really motivates you to get ready for the last 8 lessons on trig, which are all about solving any kind of a triangle problem. And then in G20, we talk about a preview of when you're going to combine algebra and geometry in a more intimate way called analytical geometry. And that is something we do starting in Tier 3 and get into it in a big way then in Tier 4, which you need for STEM mathematics. We always want to look ahead and see what's coming down the road. Now, as always, we emphasize that you need to do a lot of practice. That's why we've given you many, many more problems to do. You want to go back and review whenever you forget something. A lot of repetition. The more you practice, the better you get, the more fun it gets, and the better you'll be able to do well in the real practical world.